For today's lesson, we're going to start in on section 8.5. We will do the first part of it today, applying inequalities. We're going to take our inequalities. We can see how we can use inequalities actually to help solve some real life problems. When a quantity is said to be more or less than another quantity, an inequality can be written using your greater than or less than signs. And we will see how we can use those in some examples here. When we solve those inequalities, that will give us a range of solution for our answer. Now, an ellipses, okay, these are these fancy brackets right here. That's called an ellipses with the dots. Actually, those are the ellipses that come before or after. And that means that any numbers before the -3, any numbers after 3, right there. This set notation can be used to list the set of all integers. This shows us all integers that are possible. We could use algebraic expressions to represent 3 consecutive integers. Consecutive means numbers that come right in a row, right? So if we have 3 consecutive integers, we could say the first one is x, the next one is x plus 1, and then the one after that is x plus 2. Now, if we have 3 consecutive odd integers, or even, okay, we could say the first one is x, the next one is x plus 2, and the next one after that is x plus 4. Those would be 3 consecutive odd or even integers. Okay, let's take a look at an example here. We have, suppose Anne has 4 fewer lamps than Emily, and together they have more than 20 lamps. What is the minimum number of lamps that Emily could own? So, minimum number, that means it's got to be your final answer is going to be greater than. Okay, now first we need to define our variable. Okay, so we need to define how many lamps does Emily have. Okay, L for lamps is going to be the number of Emily's lamps. Together, N plus Emily's is more than 20 lamps. So Anne's is 4 fewer, so that means L minus 4. Okay, Emily's is L, right? And then Anne's is 4 fewer than Emily's, so here's Emily's, L, minus 4. But when we add their number of lamps together, Anne's plus Emily's is going to be greater than 20. So there's our equation. We don't have to solve this one yet, so you don't have to worry about that yet. But here is the equation. Anne's lamps, Emily's lamps, together they make up more than 20 lamps. Okay, let's suppose Larry wants to spend no more than $6 for lunch. If he has already purchased a drink and tater tots for $2.45, how many hot dogs can he purchase if they cost $1.25 each? So we have to define our variable. H is the number of hot dogs. Okay, now he already spent $2.45. So we can add that into our equation already, because that is the set amount that he already spent. Then you're trying to find the number of hot dogs at $1.25 each that he can spend. When you add that together, because it's the drink plus the tater tots plus the hot dogs, that is going to be less than or equal to $6, because he can only spend $6 for lunch. And then so it's got to be less than or equal to 6. So there is our equation once again. All right, now Mr. Tobin wants to buy 4 new tires and spend less than $250. Yes, car tires cost a lot of money, okay? What is the range of the prices that he can spend per tire? So we're going to define our variable first, okay? N is the cost per tire. We don't know how much each tire is going to cost. That's what we have to find out. And he's going to buy 4 of them because for the entire car. So 4N is going to be less than $250. He wants to spend less than $250 on these tires. So when we solve for N, we have to divide by 4. 250 divided by 4. And then that's going to give us a value for N. Okay, N is less than $62.50. Because when you divide 250 divided by 4, that's what you get. And N, each tire is going to be less than $62.50. Okay, that's what he's going to spend. Now, consecutive integers, okay, we already talked about that. Consecutive means numbers that come right in a row, okay? Integers, N. If I have 3 consecutive integers, I'm going to represent that as N. N plus 1, N plus 2, N plus 3, N plus 4, okay? For even integers, I'm going to use N, N plus 2, N plus 4. Odd integers, N, N plus 2, and N plus 4. Now, let's take a look at an example here, okay? The sum of 3 consecutive integers is more than 20. What are the smallest possible values for the integers? So first we have to define our numbers, okay? The variables. N equals the first integer. N plus 1 now is the second integer. N plus 2 is the third integer. Okay, and then it says that these 3 consecutive integers is more than 20. So more than would be greater than 20. So here's our numbers. N, N plus 1, N plus 2. Those are all added together because the sum is greater than 20. Okay, what are the smallest possible values for these integers? Well, we have 3n. Okay, if you simplify this, you get 3n plus 3. And that's greater than 20. So now I can solve for n. First, I'm going to move plus 3 over to the other side by subtracting 3. Okay, because this cancels out, becomes 0. And then I get 3n is greater than 17. And if I divide by 3, I can solve for n, and that's going to be greater than 5 2/3. Okay, now here's the fraction. N is greater than 5 2/3, but we want an integer. So we're going to round this up because it's got to be greater than 5 2/3, right? So 5 is not going to work. The next greater integer is going to be 6. Okay, so n is 6, the smallest possible integer value for n. Then your consecutive integers would be 6 plus 7 plus 8, or 6, 7, and 8. Those are your 3 consecutive integers that you are trying to solve for here. And if you check it, you plug it back in, does 6 plus 7 plus 8 give us a number that is greater than 20? Yes, because 21 is greater than 20. So then your numbers, your integers, have to be at least 6, 7, and 8. Now for the homework for this section, you're going to complete numbers 5 through 14. Okay, so hopefully this will get you to a good start for applying our inequalities into our word problems.